This is the operational description for a distributor type ignition. And first I'll go through the parts. Obviously we have to have a battery, so that's there. This is our ignition switch. When you jump in the car and turn the key, that's what's going to control whether the car is cranking over or running. We also have the distributor. That's this piece right here. That's this whole thing. And you would normally not see it from on top. You would see the distributor cap itself sitting down on top of here. We have the ignition coil. In this case, distributor type ignition system, there's only one coil. We also have the electronic control module. This is the brains, and inside the brains, this is where all of the figuring out will do. And we also have a rotor right here. This rotor sits and is attached to the top of the shaft that comes from the camshaft, and it turns as the camshaft turns, and it distributes spark to each one of the spark plug terminals. So let's get to the operation. Inside of our battery we have 12.6 volts. The whole point of an ignition system is to generate enough electricity to jump across this little gap right in here at the spark plug, and to do it at the right time. So we need to do those two things. We need to generate about 10,000 volts here to jump across the spark, and we start out with 12.6. How do we make that happen? Well, you jump in the car, you turn the key, and you start cranking the engine over. As soon as you start cranking the engine over, power flows through your ignition switch and up into your electronic control module. Your electronic control module starts to make a few decisions. It says, I'm going to send some power to my magnetic pickup. When the engine is cranking over, when you've turned the key, that means this reluctor or armature wheel, the reluctor wheel I'm going to call it, starts to spin. When it starts to spin and go round and round and round, these little teeth on the reluctor wheel interrupt the voltage signal, the magnetic field created inside this magnetic pickup, and that sends a signal back to the electronic control module. The electronic control module then sends goes this way, sends a signal to the positive through the primary windings, out the negative, and back to the electronic control module. At exactly the right time, the magnetic, this circuit, the circuit where the primary circuit is inside of here disconnected. And so as soon as you disconnect that, that means power stops flowing through the primary windings. Well, let's get some secondary windings in here. Our secondary windings go from the distributor cap all the way to the coil, and they have many windings, about 10,000 windings. We want 10,000 volts, so we're going to give it 10,000 windings. So this is what happens. As soon as the primary circuit is disconnected in the electronic control module, the magnetic field that's around the primary windings collapses. It tries to collapse into the secondary windings, but the secondary windings won't let it, because, and this is where we flow down through the rotor, and that will be delivered eventually to here. And the reason why it can't jump across is because there is a gap in the spark plug. It's not a complete circuit. So the magnetic field tries and tries and tries. That time is called the dwell time. It's dwelling and building up pressure and pressure and pressure. Remember, pressure is voltage. And so the magnetic field builds up pressure until there's enough pressure or voltage to cause current to flow and jump across the spark plug gap. As the engine is running, this reluctor wheel is turning, and as the reluctor wheel is spinning, these teeth interrupt this magnetic pickup here over and over and over again, causing the whole system to happen. At the same time, the rotor is turning, and it's going from one to another spark plug, so this would lead over to another spark plug over here, to a ground, okay? And so it would just keep turning and turning and turning, and this looks like it's a 4-cylinder engine.